a capitalist world. So we'll start with, and everybody runs after money. We'll start with the money part. So the Canadian agriculture contributes around like $36.3 billion in the Canadian economy, which is around the Canadian economy is around $2 trillion. So which is around 1.8% of this, and it also contributes in job opportunities. Around 250,000 people in Canada are like sustaining by Canadian agriculture. The Canadian agriculture also covers around 6% of Canada's land, which is less because the Canada is the second largest country in the world, but like most of the land is covered with snow for the 12-month part. And the concentrated part for the agriculture is these three provinces, that is Quebec, Ontario, and Alberta. So from the pie chart, you can see that other than agriculture, uh, service and industry also plays an important role in the Canadian GDP. Then comes to the poultry sector and contribution in the Canadian GDP. So the poultry sector, which my focus is on, contributes around $6.3 billion in the GDP, and which is around like 80%, 18% of the agriculture part. And the economy generated by the egg industry is around $1.3 billion, and there are around like 2,800 chicken producers in the poultry sectors in Canada, around 500 turkey producers, 1,200 egg producers, and also the uh, export of poultry items worth around $150 million is being exported to around 25 countries from Canada. So let's look at the poultry sector now. So the poultry sector is really important in Canada for the food supply because it's a cornerstone for the food supply in Canada. Everybody's life dependent on it over here. And it's also really important for the employees, because it generates around like 250,000 jobs every year. Um, and it's a very resource intense work because for a farm, there should be around like hundreds of poultry animals. And for that, the farm will require a shed and also human interference to manage the poultry animals. From the graph, you can see that the production of uh, chicken is increasing continuously every year. So by 2050, it is expected like it will double from what it is today, which is around like 100 million. It will go about like 200 million tons of production of chicken. So with this sector, there are certain challenges. We'll look to their challenges. The first one is the emission of greenhouse gases. So let's see the contribution of greenhouse gases by livestock. So the poultry sector contributes around 11% of the total livestock emissions, and around like 10% of that emission is from chickens only. So the sources for these emissions are mainly from the manure of the poultry animals. So the poultry dung emits certain gases which are harmful for the environment, and the main impact is like because of the greenhouse gases, the global temperature, the atmosphere temperature increases, and it traps more sunlight and it increases our planet's temperature. So, and another significant challenge is the welfare of the poultry animals. So, as you can see from this image, there are like hundreds of chickens fitted in a small shed, which is also a welfare issue. So, the main thing I'm going to do in this project, we are going to use technology, because like human lie, but technology doesn't lie. So we'll use technology for like getting the emission data. We are gonna use satellite-based image data. And also for processing that image data, we are going to use artificial intelligence for analysis part. And the main goal for this project is the poultry farmers can make strategies based on the data they are provided. And also it will improve the ethical farming practices. So the poultry animals can be uh, like uh, have a good life. So and also the uh, policy development can be made using the data from the satellite. So it can be used to decrease the emissions, GHG emissions. And also our main goal is for net zero. So every country, almost 130 countries have made commitment of making their own country carbon neutral. And Canada also had made commitment, and that commitment is around Canada wants to become carbon neutral country by 2050. And for that, uh, this project can be an important part for the poultry sector. So now comes to the data gathering part. So the first and the most important part is selection of poultry farms. So there are around 1,000 farms selected for this project, and most of them are concentrated in the Ontario region. Then comes retrieval of information from the farms. So we'll need information regarding the farm size, then the number of poultry animals in it, which are directly related to the emissions which the farm is emitting. Then we'll need the emission data from the satellites. So we are going to use data from two satellites. The first one is the Sentinel-5P. It was launched in 2017 and it was operational from 2019. So for this project, the scope is for 5 years, from 2019 to 2023, because only for that 5 years we have the data of methane emissions. And also we are in talks with another company called GHGSat, which will give us data for the farms. And the last part is integrating both this database, the farm database and the emission data. Now comes the part of processing. So the first thing is to clean and normalize the data, and also the formatting. So for getting the data, after selecting the poultry farms, we'll need KML file of that whole farm list. And the KML file is key map, key whole markup language, which contains all the geolocations of the farms. Then for getting the methane emission, we are going to use Google Earth Engine, which only takes the shapefile of the shapefile, which is a vector data set. So we have to convert the KML file to the shapefile first, and then import it to the Google Earth Engine, which will use a data set containing all the data from Sentinel-5P and will give us the methane emissions of the data. And also, this whole data set contains sensitive data of the farms and their emission data. So we have to encrypt this, and so no one other than the access control one can access it. Then comes to the most important part, which is the machine learning part. So we are planning to do this type of analysis. Like the first one is time series forecasting. It will be useful for the future prediction of methane emission, and also getting to know about trends and patterns in the emission data. And we are thinking of using models like ARIMA and LSTM for this part. Then comes to spatial analysis. This type of analysis can be helpful in getting a correlation, a spatial correlation with some environmental impacts. And the models which we are thinking of using this are clustering models. So K means clustering, that can be useful over here. Then anomaly detection. So if a farm is emitting abnormally high or low methane emission. We can find out the reason, and it can be because of any operational issue or any extra another issues. So we can get to know about that by this type of detections, and we can use like some kind of unsupervised learning in this part, like SPMs. The last analysis we are going to do is regression analysis. In this part, uh, the most will get to know the dependence of the methane emission with another features like the farm size, number of farm animals, and the models we can use for this analysis are like linear regression or like random forest. So the next part is getting like the insight of from this machine learning data. So we can get like the emission measurement from this. Then we can scrutinize the resource we are using for the farm. Then we can monitor the poultry animals' welfare, and we can also promote the ethical farming techniques by which by using this the welfare of poultry animals will improve, and which may result in decreasing the methane emissions. So, and the last part of the project is designing a dashboard. So, um, the end user for this project is poultry farmers. So, we have to design a user-friendly and engaging design. And also, the farmer would be a non-technical user, so it should be accessible to them too. Then the dashboard will have data visualization for the insights we get from the analysis part, and also it will contain real-time data processing tools. So now I will show you the preliminary analysis which I have done. So here is the data for the 1,000 farms and processors which I have studied. So like you can see from the graph that the most of the farms and processors are from Ontario, then comes British Columbia, and then Quebec. So next. And here's the graph for methane emission. And here you can see like from year to year, the methane emissions for every province is increasing. But the methane emissions of Ontario and like the big provinces are increasing drastically. Now, here's the same data in a heat map, and here you can see the values. So it's in like hundreds of thousands. The emissions from Ontario is like too much more than like some smaller provinces. And here you can see like the northmost provinces, which have like really less number of poultry farms, they emit really less because of the number of farms. And then here, from here's the methane emissions of like all farms combined. And here you can see there is a pattern. Like at the end of the year, there is a spike and then it comes down again. So from this, we can say that the here at the end of the year, it's festive season, like Christmas time. So uh, production of poultry animals increase during that time, so that the emissions also increases. Then here's the graph showing like methane emissions by their category. Category means like farms or processors. So here you can see that the emissions from farms are more than the of processor, because we have studied like more number of farms as compared to the processors. Yeah, these are the reference which I have used for developing these slides. Thank you.
Yeah, thank you. Thanks a lot for the presentation. Like we had a better idea on about the greenhouse gas emission benchmarking with satellite data like Sentinel. This is a new arena for us, and thank you for introducing us to this. And over to the participants for
Yeah.
any questions.
Hi everyone. Hello. Your presentation
Hello.
is very nice, and my question is like you are working on the greenhouse gas emissions
Hmm.
from the poultry. Do you have any plan of converting them into any usable like from the cattle we are converting the methane into the gas, cooking gas
Hmm.
like that. Is there
Yeah.
anything you have planned?
I have not planned anything, but like if there is like possibility that the poultry dung, which can be used to create cooking gas, it is possible.
Mm.
But I think the amount of dung which are like extracted from cattle is far more than amount of dung extracted from poultry animals. So it's not feasible, I think.
Yeah, that is one option. In another option, there is integrated farming where you have poultry and fish together. So here they don't feed the fish, but they live on the fecal matter from the poultry itself. So have you tried that?
Uh, I haven't tried that. Have to research on that.
Okay. Okay, because I don't know the Canadian
Hmm.
climate. In a tropical climate, it is possible because we do have the integrated farming systems where we have the poultry or the goat and then the fish together. So they live integrating or depending on each other. So the fish water is frequently removed because it's toxic ammonia is there.
Hmm. Yeah.
So it is removed and it is used for irrigating the crops. And again, it is recycled like that. It is going on. Like I want to know, maybe you can try in a smaller scale in Canadian climate. Maybe it will work out in capturing the greenhouse
I'll
gases.
try that.
Okay, thank you.
Very good presentation, uh, Umang Mehta, right?
Thank you.
Very good presentation.
Yeah.
This is very important topic because whole world is moving towards the climatic change, greenhouse control of greenhouse gases. So everybody started talking this. So definitely proceed this work and do some advancements. Um, so good amount of awards are waiting for you. Best wishes.
Thank you.
Because this is a rare area where people will work because measuring the greenhouse gases is not a simple work. It's time, it will consume your time, and not only it's data collection is very difficult. That too area specific data is very difficult. Collection of data, yes, you have
Yeah.
collaboration with space, NASA, yes, they are helping you, but
Yeah.
highly populated
We are
countries
planning
like India,
to.
it's a very challenging one task.
Yeah. We are planning to collaborate with European space agencies.
Yes,
We
yes.
are in talks with them.
So, ma'am, we also, if possible, we will also try to do this collaboration because our India is having very good poultry industry. The industry is moving in the growth of 8.5% every year. So, last 4 years back, and it was growing at 11 to 12% growth rate. Now, because of this pandemic, it reduced to 1 to 2%. So, we have very huge poultry population. So, we'll definitely work on this. Possible, we will try for the collaboration with the space agency also. We can also do this work. Uh, Very good presentation. Thank you so much.
Thank you.
Hi, Uma. That was a nice
Hi.
presentation. Uh, Able to hear me? Hello.
Yeah, I am.
Hi, Umang. That was a nice presentation. Uh, uh, can you elaborate a little bit
Thank you.
on that satellite image processing techniques? You have said you have mentioned like time series data, right? Can you
Yeah.
please elaborate a little bit?
Like, do you want to know about like how I am extracting data from it, or do you want to know about the
The
analysis part?
processing techniques, like in ML, how you incorporate it, kind of thing.
Okay. So like I'm getting data from the satellites. Till now, I have like data from Sentinel 5P, and like For the ML part, for time series data, I'm considering like two models, the ARIMA one and another is like create own LSTM one. I started with the ARIMA one, but as of now, like there is a limited data problem. So the accuracy of that model was not that good. So I'm like waiting for some new data from another satellite, and after that, I'm like I will go again for the model training part.
Okay. Thank you.
Any other questions? Yeah. Thanks a lot, Dr. Umang Mehta, for your insightful session. So participants, like we can break for 10 minutes and we'll join back at 10:20. We are posting a link here for the post-break session. So we have some issues with the Teams account. So we'll join through a Gmeet post-break. So we'll be posting the joining details of the meet here. So post-break at 10:20, we'll join using Gmeet. Thanks a lot.